Okay, so tonight we're going to talk about implicit differentiation. Now, maybe you have heard of this. Maybe you've read about it. Maybe you tried to look at some of the example problems. But really, implicit differentiation is just an application of the chain rule. What, you say? Well, check this out. So if I give you this problem here, and I just let u equal this, and I say, okay, let's take the derivative of that. Well, almost all of you can probably do 7 x cubed plus 5x times squared plus 5. Okay, got it? And so what's going to happen is we're going to do the same thing, but I'm going to give it a different name. So check this out. So this is from the chain rule, right? Everybody knows this. But watch this. What if I said, let y equal x cubed plus 5x? So then what would the answer look like? Okay, so then you'd have y to the 7th. And then the derivative would be 7y to the 6th times y prime, right? Now, the reason we have to go through this is because I'm taking the derivative with respect to x, right? So 7y to the 6th y prime, which is just the same thing as I have here. And that's implicit differentiation. Okay? This is how it works. All right, so you already know the chain rule part. So now let's kind of formally, let's put this in words, okay? When we differentiate a relation that's not necessarily a function, right? We use implicit differentiation. We use implicit differentiation. Now, what does that mean? Here's an easy picture. This is our friend, a circle with a tangent line. Well, if I know the equation of that circle, can I get the slope of that tangent line? Well, the answer is yes. So let's say this is our friend, x squared plus y squared equals 9. Now, here's the key to all of this. All right? Know the variable with respect to which you are differentiating. Okay, do I want to find dy dx? Do I want to find dx dy? Because it matters. And I'll show you. So let's say we want to find dy dx. All right. So I'll pause here if you want to write the rest of this down, but why don't you pause it and see if you can do this derivative. So if I want to find the derivative with respect to x and I'm differentiating x, I'm good. 2x. But now I'm differentiating y. Oh, wait a minute. What did we do over here? Y to the 7th was 7y to the 6th, y prime. What do you think y squared is going to be? If you said 2y prime, you'd be correct. Because I don't know what y is. Y's not x. 2y dy dx. And then the derivative of 9 is 0. Then we're done with the calculus. See, there's two parts to implicit differentiation, the calculus and the algebra. That's the calculus. We're done now. Now we do the algebra. We have to solve for dy dx. Well, negative x over y. But now, let's do something a little bit different. Let's find dx dy. Now, do we ever do this in practice? Mostly we don't. I mean, how many middle school teachers would have a cow if you said run over rise for slope? I would like to find the change in x every time y goes up by 1. They'd say, no, you have that backwards. Well, you only have it backwards because that's how we've defined slope. But let's say I wanted to find dx dy. Now look what's happening. I'm taking the derivative with respect to y. Those are key words, okay? With respect to y. That's a y variable, isn't it? So with respect to y, that just becomes 2y. But what do you think x does? I'm taking the derivative with respect to y, so I don't know what x is. It's not y. 2x dx dy. Derivative of 9, 0. Algebra pants. They still fit, kind of like skinny jeans. But there they go. Negative y over x. Now, everything that I'm going to do is going to be some version of this right here. The rest of the problems that we write just try to make this more complicated. But in the end, if you just ask yourself, what am I differentiating with respect to? And if it's x, then every x term just has a derivative like normal. And if it's not x, most of the time it's going to be y, but it doesn't matter. Any other variable, you would take the derivative like you normally would. Derivative of y squared is 2y. Derivative of sine y is cos y. But then you have to do times dy dx. Just like we did here with the chain rule. Something to the 7th is 7. Something to the 6th, derivative something. Something squared, 2 something, derivative something. And that, my friends, is implicit differentiation. An explicit solution to implicit differentiation.